Welcome, grade 9 students. HALINA'T MATH-TUTO. We are now in fourth quarter period, and in week 1, we will discuss about the 6 trigonometric ratios. But before that, let's have first the lesson's objectives. At the end of the lesson, the learners are expected to: number 1, illustrates the 6 trigonometric ratios. Number 2, identify the 6 trigonometric ratios in a right triangle. And number 3, determine the ratio to be used in solving the unknown parts of the right triangle. These objectives are based on the most essential learning competency prescribed by the Department of Education in week 1 of quarter 4, which is illustrates the 6 trigonometric ratios, which are sine, cosine, tangent, secant, cosecant, and cotangent with a code of M9GE-IVA-1. Let's now start discussing trigonometry. Since ages ago, navigators, surveyors, and astronomers have used triangles in measuring distances, especially those that cannot be measured directly. Measuring directly means to use a ruler, a meter stick, a tape measure, or devices that measures length and distances. Trigonometry is a branch of mathematics that deals with the relation between sides and angles of a triangle. It also comes from two ancient Greek words, trigon, meaning triangle, and metron, that means to measure. Thus, literally, it means measurement of triangle. The Pythagorean theorem that has been discussed to us from quarter 3 is used to solve for a right triangle. However, its use is limited only to solve for the unknown sides of the right triangle. But how can we solve if one side and the measure of one angle is given? Solutions for this kind of problem makes use of trigonometric ratios. Trigonometric ratios are defined by means of the acute of the right triangle. Let's discuss the right angle triangle. We all know that a right triangle is a triangle whose one angle measures 90 degrees. Based on our given figure, we have here the Greek symbol theta, which denotes as our angle. We will also use the convention that angles are symbolized by capital letters, while the side opposite each angle will carry the same letter symbol in lowercase or small letter. Let's discuss now the sides of a right triangle. First, we have the adjacent side. Adjacent is adjacent or next to the angle. On this figure, if this will be our angle, the adjacent side is small letter A. Next, opposite side. So, opposite the angle. Again, on our given figure, side B is the side opposite of our given angle here, or our theta. Last one, the longest side is the hypotenuse. Always remember that the hypotenuse is the side opposite of the 90-degree angle. Since angle C is our right angle, therefore the hypotenuse is side C. Let's now start discussing the 6 trigonometric ratios. So we have the sine, abbreviate with SIN, cosine, cos, tangent, tan, cosecant, CSC, secant, sec, and cotangent abbreviate with cot. Sine, cosine, and tangent are seen in our scientific calculators. Cosecant, secant, and cotangent are known as the reciprocal of sine, cosine, and tangent, respectively. To continue our discussion, we will now have the primary trigonometric ratios, which is known as the SOHCAHTOA. SOHCAHTOA is a mnemonic used in remembering the equation. So we have here triangle ACB given our theta or angle, which is angle B. The side opposite of angle B is side B. The side adjacent to angle B is side A, and the hypotenuse is side C. Let's start with SOH or SO. SO is an acronym for sine theta is equal to opposite side over hypotenuse. Based on the given figure, the opposite side is side B and the hypotenuse is side C. Therefore, sine theta is equal to B over C. Ka means cosine theta is equal to adjacent side over the hypotenuse. So again, based on our figure, the side adjacent to our theta is side A, and the hypotenuse is side C. Therefore, cosine theta is equal to A over C. And TOA stands for tangent theta is equal to opposite side over the adjacent side. Since our given opposite side is side B and our adjacent side is side A, therefore, tangent theta is equal to B over A. We also have the reciprocal of SOHCAHTOA, which is CHOSHAKAW. The reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So again, let's have our given figure. So we have here CHO. So CHO is an acronym for cosecant theta is equal to hypotenuse over opposite side. So again, since that our hypotenuse is C and the opposite side is B, so cosecant theta is equal to C over B. Next is SHA. SHA stands for secant theta is equal to hypotenuse over adjacent side. So again, the hypotenuse is C and the adjacent side is A. Therefore, we will have here C over A. And COW, which stands for cotangent theta, is equal to adjacent side over opposite side. So adjacent side is A and the opposite side is B. So cotangent theta is equal to A over B. Let's now have the first example. So find the 6 trigonometric ratios. Given here is triangle ACB wherein side A is 3, side B is 4, and side C is 5. So we need to find out what is sine A, cosine A, tangent A, cosecant A, secant A, and cotangent A. So we will focus only to angle A. So what is the measure of the side opposite of angle A? That's right. That will become 3. The measure of side adjacent to angle A is 4 and the hypotenuse is 5. We are only looking for angle A. So this will be our focus. So sine A, which is opposite side over hypotenuse. So we have opposite over hypotenuse. Therefore, sine A is equal to 3 over 5. Next is cosine A. So again, cosine is an acronym for adjacent side over the hypotenuse. So this will be our angle A. So the side adjacent to angle A is 4 and the hypotenuse is 5. So we will have here cosine A is equal to 4 over 5. Next is tangent A. So tangent or tangent theta is equal to opposite side over the adjacent side. So the opposite side or the measure of the side opposite to angle A is 3 and side adjacent is 4. So we will have here tangent A is equal to 3 over 4. Next, cosecant A. Since cosecant A is the reciprocal of sine A, so cosecant A is hypotenuse over opposite sides. So, we will have here 5 over 3. Next is secant A. So, secant A is hypotenuse over adjacent. So we will have here hypotenuse is 5 and the adjacent side is 4. So secant A is equal to 5 over 4. And cotangent A is the reciprocal of tangent A. So we will have here 4 over 3. Since that cotangent theta is equal to adjacent side over opposite side. Let's have another example. So find the 6 trigonometric ratios. Given here is triangle ACB, wherein side B is 7, side C is 25, and side A is unknown. Since one of these sides of a right triangle is unknown, we need to use the Pythagorean theorem. So we have here C squared is equal to A squared plus B squared. So substitute the value of C, which is 25, and the value of side B, which is 7. So we have here 25 squared is equal to A squared plus 7 squared. Next is to evaluate. So 25 squared is 625 is equal to A squared plus 7 squared, that is 49. Combining like terms, we will come up with A squared is equal to 625 minus 49. So that will become 576. So get the square root of both sides. So we have here square root of A squared is equal to square root of 576. So we have A is equal to 24. So we need to find the 6 trigonometric ratios of angle B. So we have your sine B, cosine B, tangent B, cosecant B, secant B, and cotangent B. So let's analyze the right triangle. So this is angle B. So this will be our focus. The side opposite of angle B is 7. This side adjacent to angle B is 24. That is the value that we got a while ago. And the hypotenuse is 25. So, in order to get sine B, so that is opposite side over hypotenuse. So, opposite of angle B is 7 and the hypotenuse 25. So we will have here sine B is equal to 7 over 25. Cosine B is adjacent side over hypotenuse. So adjacent side is 24 and the hypotenuse is 25. Therefore, cosine B is 24 over 25. Tangent B. So, tangent theta is equal to opposite over the adjacent side. So, we will have tangent B. So, we have opposite side is 7 and the adjacent side is 24. So, tangent B is equal to 7 over 24. Next is to find cosecant B. So, get the reciprocal of sine B. So, that will become 25 over 7. Next is secant B. So, secant B is equal to 25 over 24 since that secant theta is equal to hypotenuse over the adjacent side. And to find cotangent B, that is adjacent side over the opposite side. Therefore, cotangent B is equal to 24 over 7. Let's move on now in showing a formula for the missing parts of a right triangle. Given is triangle BAC wherein angle B is 65 degrees and side A measures 17. So we need to solve for side B, side C, and angle C. So let's analyze our given triangle. Side B is the opposite side of our given angle, which is 65 degrees, or our angle B. Side C is the adjacent side of 65 degrees. If we will solve for side C, then we need to use ka, or cosine theta is equal to adjacent side over the hypotenuse. So our given angle is angle B. So we have cosine B is equal to C over A. So let's substitute the values. So cosine 65 degrees is equal to C over 17. By cross multiplication, so C is equal to 17 cosine 65 degrees or 17 times cosine 65 degrees in order to find the measure of side C. Now let's have side B. So to solve for side B, we need to use SO or sine theta is equal to opposite side over the hypotenuse. So we will have here sine B is equal to B over A. So we have sine 65 degrees is equal to B over 17. By cross multiplication, we will come up with B is equal to 17 sine 65 degrees, or to find the measure of side B, so we need to multiply 17 by sine 65 degrees. Now to find angle C, since the sum of the angles of a triangle is 180 degrees, we need to add the given two angles, then subtract to 180 degrees. Now we will now have the measure of angle C. So as you can see, angle A is 90 degrees, angle B is 65 degrees. So in order to find angle C, add 90 degrees to 65 degrees and then subtract to 180 degrees. So let's wrap up our discussion. So we discussed about the 6 trigonometric ratios, which are sine, cosine, tangent, cosecant, secant, and cotangent, and its mnemonic, SOHCAHTOA, and CHOSHAKAW. For easily remembering the equations, And we also discuss on showing the formula in finding the missing sides and angles of a right triangle using the 6 trigonometric ratios. Okay, so for our exercises, so kindly get a pen and a paper and try to answer what is more. So given triangle MAN, so we need to find sine M, cosine M, and tangent M. So based on our given figure, side N is 5, side M is 12, and side A is 13. So by using SOHCAHTOA, we can find what is sine M, cosine M, and tangent M. So in your notebook, kindly answer the following questions. What have you learned in this topic? And cite a situation that applies trigonometry and explains how to determine what trigonometric ratio to use when solving for the unknown parts of the right triangle. In solving for the unknown parts of a right triangle, it will be discussed further in our next lesson. And that is the end of our discussion. So thank you for listening.